Let's write B in terms of A. We are given the areas A and B, where the area of B is 4 times the area of A. For this, we will evaluate the areas using the area under the curve formula. We will evaluate the area A as well as evaluate the area B using the formula, and then we will make this condition, and then we will write the B in terms of A. So first, let me write the formula to find the area under the curve. Suppose if we have a curve y equals f of x, which is continuous and defined under the interval a comma b, then the area under this curve is given by integral from a to b f of x dx. Or otherwise, we can also write down this as an integral from these limits are x equal to a and x equal to b, that is x equal to a and x equal to b y dx. So this is the formula that we are going to utilize. So let me find the area under the curve. This is the first curve. Let's say if this is first curve and this is the second curve. In fact, both curves are the same because the curve equation is y equal to e power x, y equal to e power x. However, the intervals are entirely different. So let's find out for the curve 1. So I'm going to write down this area as A. So this is equal to the lower limit of this curve is this is start from 0, that is from origin. So I put 0, and the upper limit of this curve, that is the region, is A. And then I put this curve equation, that is y dx. Now I can replace the y by e power x because the curve equation is y power e power x. So let me substitute for y. So this becomes e power x dx. Now we can integrate this using the standard integration formula. Integration of e power x is e power x, and then we have to apply the limit starting from 0 to a. So this can be written as e power. When we apply the upper limit, we have to apply the upper limit as well as the lower limit, and when we do that, we get e raised to the power of a minus e raised to the power of 0. So this gives us e raised to the power of a minus e raised to the power of 0 is 1. So we have found the area of the curve y equal to e power x defined under the interval 0 to a. Basically, we found a value for a equal to e power a minus 1. Now in the same way, let's find out for the second curve. Let's find the area B. So I'm going to write down for B. Here also we use the same formula. However, the limits are 0 because the lower limit is 0. However, the upper limit is B. So let's do that. So I'm going to change the limits from 0 to B, and then I put the curve equation y dx. I replace the exact equation for y. Here as well the curve is e power x dx. So let's integrate. So once again, if we integrate e power x, we get e power x, and then we put the limits 0 to b. Now we substitute the upper limit as well as the lower limit. So therefore, this becomes e raised to the power of b minus e raised to the power of 0. So this gives e raised to the power of b minus of 1. So basically, we have found out the value of b. This is the area. Now using the given condition, we are going to determine the value of B or express B in terms of A. We are given that area of B is 4 times the area of A. So we can write down an expression using that condition. That is area of B is 4 times the area of A. Now let's substitute the corresponding areas. We know A equal to e raised to the power of A minus 1 and B equals e raised to the power of B minus 1. So I'm going to replace B by, that is capital B, by e raised to the power of b minus 1. This is equal to 4 times of e raised to the power of a minus 1. So I'm going to simplify this and solve for the little b from this equation. So first let me add or I distribute this 4 into this expressions, that is into the terms. So therefore this becomes 4 times of e raised to the power of a minus 4 times of negative 1 is negative 4. Now I can add 1 to both sides so that I have only e raised to the power of b on this side, and on the right side I will have this is e raised to the power of a. Negative 4 plus 1 is negative 3. So I get like this. Uh, I have to solve for b, so I'm going to take a natural logarithm on both sides. So when I do that, I get natural logarithm of e raised to the power of b equals natural logarithm of 4e raised to the power of a minus of 3. Now we apply the property or the power rule property of this logarithm, so that this e raised to the power of b, this power b will come in front. So I can write down this as b times of natural logarithm of e equals natural logarithm of 4e raised to the power of a minus 3. Now we know the property of logarithm, that is natural logarithm of e equal to 1. That is the value of this natural logarithm of e equal to 1. So therefore this becomes b times of 1, which is b. So we have only b on the left side. This is equal to natural logarithm of 4e raised to the power of a minus 3. So we have written b in terms of a. So this is the final required expression. We have written b as an expression involving only a on the right side.